Now, before I start, I still would like to thank Cynthia for the nice introduction, and also thank you for your work time for organizing this wonderful workshop. We are going to benefit a lot, and we are going to learn from each other. Also, thank our first two lectures. I hope that I could take some course with you too when I was a graduate student, but I did not. Also, thank our every colleague for coming. Now, what I'm going to talk about today is the indicator variable. Now, when I trying to teach Stats 330 and Stats 333, at the beginning of the class, I would like to give a review about the indicator variable and then how we're going to use them. There are two reasons for me to do that. The first reason is that I think indicator variable is easy, so it's easy to teach. Second reason is that I found it is very useful, so I say I'm going to teach that. So today I'm going to cover two things. First of all, what is the indicator variable, and then how we're going to use it. Now, if I have time, then I give a summary. Now, here's the indicator variable. Indicator variable can only take two values, 0 and 1. Now, if you have an event, in statistics, we are talking about an event. So if you have an event, we can define the corresponding indicator variable. Now, the event is A, the indicator variable is IA. So the IA will take value 1 if the event A occurs, or take value 0 if the event A does not occur. I always toss a coin and toss a die with my son, so I give a toy example here. Now, suppose we toss the coin just once, and then there are two possible outcomes, that's the head and the tail. So I will use the head to denote H and H to denote head, sorry, and then T to denote tail. Now, A is getting the H in a toss, and then A is going to be an event. So that's the concept of the event. And then we define the corresponding indicator variable, IA. So IA is equal to 1 if we get H on the toss, and then if we get T on the toss, IA is going to be 0. So it is an indicator variable because just two values. Now, let me move forward. Now we know what is the event. We define what is the indicator variable. So we use the A and I to denote them. Now, what we are interested in is the expectation. We use the notation EIA. Now, by the definition of the expectation, we can calculate the expectation of IA. So it's just 1 times the probability I equal to 1 plus 0 times the probability of I equal to 0. Now, in general, the expectation is the summation of the possible value of IA times the corresponding probability. So we have two possible values here, each one times the corresponding probability, and then we take the summation. Second part will cancel out, and then we only have the first part. So the conclusion here is that the expectation of indicator variable is just the probability of indicator variable equal to 1. Now, that's what I wrote here. It is very simple, but it's going to be very useful here. Now I move to the one particular application of indicator variable in statistics. I would like to give one comment here is that indicator variable looks very, very simple. It only has two values. The expectation of indicator variable is just the probability of indicator variable equal to 1. But if we know how to use it effectively, it will be very, very helpful. Now, the following, I will just give some examples, and then I illustrate how to find the expectation of random variable based on indicator variable. I need to drink coffee every day to start my day, so my example is about drinking coffee. Now, suppose I have to drink coffee every day in the morning. And then, now let me just assume that I just randomly pick a medium-sized coffee with probability half, and then a small-sized coffee with probability half. And I also assume that I just drink 1 cup of coffee. That's not always true, but let us assume it is true. And then X to be the number of the medium-sized coffee I drink in 5 days, so in 1 week. What will be the expectation of X? Now, when I ask this question in the class, and then most students in the class, they still remember that, OK, this X follows the binomial distribution. And the binomial distribution has two parameters. The first parameter, 5, is the number of coffees I drink. 0.5 is the probability of drinking a medium-sized coffee. And then, okay, continue. They will tell me that what will be the expectation of x, that's just the first parameter, 5, times the second parameter, 0.5. So 5 times 0.5. Again, it's easy. Now, when I ask them that, okay, how are you going to find the expectation of binomial random variable? Some students can still remember something from the previous course. They say, okay, the range of x is from 0 to 5, 0, 1, 2, 3, 4, 5. And then they still know what is the definition of the expectation. The summation of the possible value of x times the corresponding probability. So that's good. They still remember that. And I say, okay, you don't need to memorize what is p, the probability of x equal to n. I can give you that. So the probability of x equal to n takes this form. And I ask them, how are you going to figure out the final part? In theory, this summation should be equal to 5 times 0.5. But can anybody tell me how to do that? The answer is quite negative. Most people forget how to get this summation. And then, okay, I say, calm down. I have a simple solution which is based on the indicator variable, and we don't need to take the summation here. Now, here is my solution. Now, we first define 5 indicator variables. Each indicator variable for 1 day. So xi is the corresponding indicator variable for the event that I choose medium-sized coffee on the ice day. So xi equal to 0 if I choose medium-sized coffee, otherwise it will be 0. Now, what we can easily get is that the probability of xi equal to 1 is just equal to 0.5, because I have two choices, medium, small, and everyone has 0.5 probability. So after that, then I say, okay, the next step is just to say we can express x as the summation of xi. Xi, you can say xi is number of medium-sized coffee I drink in 1 day. Now, if we take the summation, then we get x is number of medium-sized coffee I drink in 5 days. So once we figure out this part, then the following is just some calculation. So I write down the equations, the sequence of equations, and then I'm going to interpret everything here. Now, this step is just because x is equal to the summation. The second step is just we exchange the order of the summation and the expectation. So that's the result about the expectation. And the next is that how we move to the third step. So the next is that what will be the expectation of xi. Xi is the indicator variable. So the expectation of indicator variable is just the probability of indicator variable equal to 1. So we came to 1, 2, 3, 4, the fourth step. And then we mentioned that the probability of indicator variable equal to 0.5. So we plug in what is 0.5, and then we take the summation. We get 5 times 0.5. So if you know how to use the indicator variable here, and then you don't need to do the summation before. So that's the story I would like to tell from this example. Let me show one more example. Thank you. Now, the background is just exactly the same as before. But in the second sentence, I just used the m to denote the medium size, small to denote s to denote the small size. Otherwise, the first 3 sentences are the same. I'm going to introduce a new thing, which is called the changeover in the fourth sentence. So we start from here. We see that a changeover occurs on the I state if the size of the coffee on the I state is different from that of the I-1 state. What we are interested in is the number of the changeovers in 5 days. Now, I give you an example here. Now, suppose I drink 5 cups of coffee in a week. So we have small size, medium size, and small size. Then the changeover will happen here and here. So the third day and the fifth day, because these 2 days are different, these 2 days are different. And then y, the number of the changeover in 5 days will be equal to 2. So in general, we need to find an expectation of y. Now, some students are really would like to try this question, and they just follow in the following way. So they first figure out the range of y is from 0 to 4. 0 means that we don't have changeover. 4 means that starting from the second day, every day we are going to be different. And they already know what is the definition of the expectation, so they just plug in n times the probability of y equal to n and take summation. But they find that it's very, very difficult for them to figure out what is probability of y equal to n in general. And they came to ask me that, oh, how should I continue? Is this question going to be covered in the final exam? Well, I say yes, because we have a very simple solution based on the indicator variable. Here's the solution. Starting from I equal to 2 to 5, we define 4 indicator variable. If a changeover occurs on the I state, then the indicator variable equal to 1, otherwise equal to 0. Now, I would like to emphasize that the first state is not a changeover, because we don't compare the first state with the 0 state. So I start from 2, and then we have 4 indicator variable. Now, before I continue, I find what is the probability of yi equal to 1. Now, changeover, we have 2 types of changeover, from S to M, and then from M to S. So probability of y1 equal to I, or the probability of have a changeover, is just the probability of from S to M plus the probability from M to S. And the first probability is 0.5 for this S, 0.5 for this M. The second probability we have 0.5 for M, 0.5 for S. So in total is 0.5. So every day we have the 50% probability to have a changeover. And then we express our y in terms of the summation of yi. So we express y to be in the summation of 4 indicator variable. So we have the summation here. Again, we just follow the previous step. The expectation is equal to the expectation y is equal to the expectation of summation. Exchange in the order. Replace expectation of yi to be in the probability of yi. And plug in 0.5, then you get 4 times 0.5. And the story I would like to make is that it's almost hopeless for the student to find the expectation yi by definition. But using indicator variable is much easier. I skipped 2 slides, and then I came to the last one. Now, at the end of each topic I covered, or at the beginning of each lecture, I would like to give a summary. Now, here I just gave 3-sentence summary. We covered the indicator variable. We covered the expectation of indicator variable. We covered how to find the expectation of random variable by expressing it as a summation of indicator variable. So that's it. Thank you.